Hi everyone, in this video I'll explain the hydrogen bonding that occurs between water molecules. Let's start off by talking about what a weird substance water is in the first place. First of all, the fact that water can be found in the liquid state is very bizarre. If you look around you, most other substances exist only as gases or solids. It's also weird that it takes a lot of heat to make water warm. You can envision a relatively small pot of water on a very, very hot stove. It takes a long time to heat that water up, or think of your swimming pool outside in very, very warm summer months, and it stays relatively cool for most of that time. Or the fact that it becomes less dense in the solid form. This is why ice cubes float in your drink or icebergs float on the surface of the water. This is strange. Most other solids are more dense and would sink to the bottom. Also, the fact that water has something called a very high surface tension. If you've ever seen those little bugs that can walk around on the surface of the water, here this spider, he's not floating on the water. You can see he's actually indenting the surface as he uses the surface tension to walk around on top of it. And lastly, the fact that water is really good at dissolving other things, like the image of this pill being dissolved. So to understand why water is such a strange substance, let's start by looking at the Lewis structure of a water molecule. So I've got that drawn here with 2 single bonds to the H's and 2 lone pairs coming off of the oxygen. Now let's take a closer look at that oxygen and something pretty unique about it. Oxygen has the property of being very electronegative. That means it has a stronger attraction to the shared electrons in the bond. So remember, these covalent bonds are actually made of 2 electrons apiece. And the electronegative oxygen has the effect of pulling those electrons a little bit closer to it than they are to the hydrogen atoms. And since electrons are negative, what ends up happening here is on this side of the bond near the oxygen, you get a slight buildup of a negative charge because the negative electrons are spending more time near the oxygen. On the back side of that bond, so we'll turn the end of the arrow into a positive sign, this end of the bond, because the electrons are getting pulled away from it, is becoming slightly positive. This type of a bond where the electrons are not shared equally is called a polar bonds, and the OH bonds in water are very polar. Here's a slightly cleaned up version of that arrow symbol you saw me draw in to represent the polar bond. The next important thing about the structure of water is the fact that these polar bonds are arranged asymmetrically. What that means is they're both kind of pulling, or the oxygen is pulling the electrons sort of in the same direction towards itself. What happens when you get this asymmetric arrangement is the atom that is sort of accumulating most of the electrons builds up a partial negative charge. And we have a special symbol to represent that partial negative. It's a Greek lowercase letter, and you put the little negative symbol in front of it. Oxygen becomes partially negative since both of the polar bonds are directed with negative charges towards it. At the same time, the hydrogen atoms, the ones that are having the electrons pulled away, become partially positive. And we use the same lowercase Greek letter, but this time with a positive sign. And here's a slightly cleaned up version of the water molecule with the partial negatives and partial positives labeled. So what we get here is a molecule, the H2O molecule, that has one side that's very negative and another side that's very positive. And this property, when the molecule has a negative side and a positive side, is called being polar, and water is a very polar molecule. This Lewis structure with these polar bonds and those partial negatives and positives is one of the key ideas for this video. Make sure you pause and take a moment to write them down. So now that we know something about an individual water molecule and its polarity, we can start to talk about what happens when there's many water molecules all together in the same spot and how they would interact with each other. The good news is we have a pretty good model for this already from our everyday lives: magnets. When water molecules are present near each other, that's exactly how they behave, just like teeny tiny little magnets. So think about it this way: if you imagine 2 bar magnets, we know that the north end of one magnet, if you put it near the south end of the other, those opposite poles will be attracted to one another. The opposite poles on a water molecule will do the exact same thing. So here's one water molecule in the middle of the screen. If I add in a second, notice how they're being attracted to each other. the negative end of this one is being attracted to the positive end of this one because opposite charges or opposite poles attract, just like the north and south ends of the magnets. And this doesn't happen between just two molecules. There could be another water molecule down here whose negative end is being attracted to this positive hydrogen, or another one over here, negative to positive, or here, negative to positive, or down here, always with the negative pole being attracted to the positive pole. And the last important detail for this video is that the interactions between H2O molecules have a name. These attractions are called dipole-dipole interactions, and they're labeled here on this model in blue. But that's not the only label that they get. The dipole-dipole forces between water molecules are actually so strong that they get a second name, a special name for significantly strong dipole-dipole forces, and these you might have heard of before. They're called hydrogen bonds. So again, the same things we had highlighted in blue, the dipole-dipole interactions, are also called hydrogen bonds, now highlighted in red. The existence of hydrogen bonds between water molecules is the second and final key idea for this video. Make sure you've paused and taken a moment to write that down. And that concludes this video on the hydrogen bonding between water molecules. Here's a brief summary.